Okay, so the first question here, 14, is to do the average temperature. And the easiest way to do that is actually to add up all the positive numbers. Take them first. So 3 and 4, that's 7. Then add up all the negative numbers and think of them as being positive numbers first, but just put a minus sign afterwards here. Think of all the negative numbers as being positive because we're adding how many negative numbers we have. We have 3 and 2, that's 5, and another 2, that's 7, and another 3, that's 10, and 4, that's 14. So we have a total of minus 14. 14 minus numbers. All divided by how many days do we have? Monday to Sunday we have 7 days. 7 minus 14 is minus 7. 14, take away 7 would be 7, but there's the larger number has a minus in front, so the answer will have a minus in front, always. And we get minus 7 divided by 7 is going to be minus 1 degrees centigrade. So the average weekly temperature of all 7 days, I think that's the easiest way to do it. Add the positive numbers together, add all the negative numbers together, take the negative away from the positive, divide by the number of days. Gives you the average. So don't forget to answer the question and don't forget to show you're working out because these are C points. Then we have a triangle and we know that this angle here is 70 and we know that this angle here is 20. Well, if we know that this is 70, then this one here must be 180 minus 70. So this one is 110 degrees. This one is 110 plus 20. That's 130. So V must equal 180 minus the sum of these two angles, which is 130 degrees, which is 50 degrees. That's one way of doing it. A simpler way of doing it is that the angle here, the 70 degrees, this angle must equal the sum of these two. 20 plus 50 must equal the same as this exterior angle, because this one is already in our triangle, and all three together and add up to be 180. So we know that this is 70, we know that this is 20, we can say straight away this one has to be 50. Because these two have to add up to be the sum of the exterior angle. So that's a slightly quicker way. Now we have a flag and they wonder what is the fraction that is shaded in our flag. Well, if we look at the first part, we can see we've actually split our shape up into parts of 8. So we can see that here, one part of 8 is shaded. But here, we can actually see that if we think of this as being 4 parts of 8, we can see that 2 parts of 8 are shaded in the bottom half. We can actually think of this as being the whole part of the bottom here is half, which is 4/8, but we've only shaded half of it, so we've actually shaded 2/8. So the amount of shaded area here would be 1/8 plus 2/8, which would be 3/8. So the amount of that flag that was shaded would be 3/8. Then we have another question where we have an algebra question. Where we have an equation, A times A plus 2 plus B. And they want you to solve it for A equals 3 and B equals minus 2. Well, we can just put the numbers in here then. 3 times 3 plus 2 would be 5. Plus B, which we know is minus 2. So we'd get it equals 15 minus 2, which would be 13. Then they've given us a number line with numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9. They actually went all the way up to 16. And they said, put the square root of 8 somewhere on the number line. Well, we know that the square root of 9 is 3, plus or minus 3. So we know that square root of 8 must be slightly smaller than that. We know that the square root of 4 is 2. So we need to be somewhere between 2 and 3, but probably quite close to 3. So we should be somewhere here on our number line, the square root of 8. And we just put in a little sketch there. Then we have question 19, where we have a dot matrix. We've got lots of dots here. I'll try and make them as even as I can. And they've drawn a triangle that goes from here and then to here and then to here. And they've told us that one of these squares like this between the dots is 1 unit area. And the question is, how big is the area of the triangle? Well, that's quite easy to work out if we actually think of it as being one big rectangle minus the 3 small rectangles that we've got. So if we're talking unit area here, what have we got on the length? We've got 1, 2, 3, 4, I think. 4 on the bottom. And we've got 2 as the breadth. So 4 on the length, 2 as the breadth. So the area of the whole rectangle is 4 times 2, which is 8 area units. And then we want the area of triangle 1, 2, and 3. So we want 8 minus area 1 minus plus area 2 plus area 3. And that will give us the area of our triangle. Area 1, well, what will that be? That will be 2 times 2 divided by 2, because it's a triangle. Mustn't forget to divide by 2 when it's a triangle. The area 2 will be 2 times 1 divided by 2. And the area of triangle 3 will be 4 times 1 divided by 2. Here we have equals 8 minus 2 divided by 2, 2 there. We get the 2's cancelling there, giving us plus 1. 2 goes into 4 twice, so we get 2 times 1 plus 2. So we get 8 minus 5, giving us 3 units of area. So the inner triangle, this one here, will have 3 units of area. Take the outer rectangle, subtract the 3 individual triangles, and you'll get the right answer there. Then I think we've only got one question left, and it's question 20. We have this equation, x squared plus x minus 12 equals 0. And you have to ring in an answer. Which of the following is a solution to the equation? Well, one way of doing this is actually trying to do FOIL backwards. And we can actually try and factorize this and come up with what the equation could end up looking like. And this is sort of a bit advanced. But we know that we get x times x. And then we have to think of 2 numbers that multiply together give us minus 12. We could have minus 12 times plus 1. Or we could have minus 6 times plus 2. That would give us 12. Minus 4 times plus 3 would also give us 12. All of these, or the other way round, could be minus 1 plus 12. But what we have to do is, when we actually add those numbers together, so if we added 12 plus 1, would we get x? No, we'd get minus 11x here. If we added minus 6 and 2x, would we get? No, we'd get minus 4. So that doesn't work, and it wouldn't work the other way around. We'd get plus 4. And we want just plus 1x. We have to get plus 1x. But minus 4 plus 3, that would give us minus 1. So that would give us minus 1x, and we want plus 1x here. So if we did it the other way around, if we did plus 4 times minus 3, let's see what happens if we put that in here. If we put that into our equation and expand it out now backwards, this would give us x squared minus 3x plus 4x would give us plus x. Minus 3x plus 4x would give us plus x. Plus 4 times minus 3 would give us minus 12. So that's how we can use that technique to factorize back. So this gives us two solutions to this equation. We have the x plus 4 equals 0. And we have another solution to this equation, the x minus 3 equals 0. This must mean that x must equal minus 4 or x can equal 3. Both of these should be solutions to our equation. And let's try it. Let's put in x equals 3 into this top equation. What happens then? 3 squared is 9 plus 3 minus 12. Does that equal 0? Well, yes, 9 plus 3 minus 12 does equal 0. So that's a solution to this equation. Let's try it for minus 4 then. If we squared minus 4, squared, we get plus 16. Plus x, which is minus 4, minus 12. So plus 16 minus 4 minus 12 does equal 0. So that is a solution. Any other number that you put into this equation won't actually work. You don't need that